Hey, Accelerated Algebra 2, how's it going? Sorry I can't be there today, but I wanted to give you the lesson nonetheless. All right, so you're going to need graphing calculator and regular paper for this particular lesson, and there are 4 boxes, and we're going to be talking about the zeros of a polynomial. So at any time, if you need to pause this while we're watching it to take your notes, go ahead and do so. So I have everything all laid out here, and I'm going to kind of walk you through what we're talking about here. So the first idea is we're going to spend some time talking about the zeros of a polynomial. And I have 4 polynomials here to look at, and they go up increasing in degree as we move along here. So the first one is f of x equals x minus 2. So we're talking about the zeros for this particular polynomial. So what we mean by that is if I set, x minus 2 equal to 0 and I solve, I would see that x equals 2. So 2 is what we call a zero of this particular polynomial function because when I plug in f of 2, notice I would get 2 minus 2, which gives me 0. So f of 2 would give me 0. So this polynomial function, notice it has a degree of 1 and it has exactly 1, 0. All right, so let's take a look at the second one here. F of x equals x squared minus 6x plus 9. Well, we can factor this into x minus 3 times x minus 3. And if I set this equal to 0 and use the zero product property, I would see that I would get x is equal to 3 and x is equal to 3. So this polynomial function has a degree of 2 and it has 2 zeros, namely 3, but we say it 3 with a multiplicity of 2. Multiplicity of 2. That just means that it happens twice. Or sometimes they call this a repeated 0. So 3 is a 0 and it's been repeated twice or has a multiplicity of 2, and notice the degree was 2 there. Alright, so let's move on to this third degree polynomial here. I have a third degree. I can factor this and factor an x out. That will leave me with x squared plus 4. And if I set this equal to 0, I could see using the zero product property that x equals 0, or x is equal to plus or minus 2i. So this is telling me that the zeros in this case are 0, 2i, and negative 2i. So all of these are what we call zeros to this polynomial function here. And you can see where this is kind of going here. X to the 4th minus 1, well, we can factor this into x squared minus 1, x squared minus 1, so that will leave me with x squared plus 1 times x squared minus 1, and I can factor this and get the zero product property that x is going to be equal to plus or minus I, or x is going to be equal to plus or minus 1. So the zeros in this case would be I, negative I, 1, and negative 1. So notice I have 4th degree polynomial and I have 4 zeros. That's not an accident. In fact, it's happening every single time. So 3rd degree, 3 zeros, 2nd degree, 2 zeros, multiplicity of 2, and then 1st degree, 1 0. So there's something going on here with the zeros of a polynomial. Before we move on, though, I want you to understand that zeros is the same thing as x-intercepts. It's the same thing as solutions. It's the same thing as roots. All of these words mean the same thing. So zeros, x-intercepts of a graph, solutions, roots, these all mean the same thing. Okay, so let's talk about the rational zeros test. Some of these zeros that we're looking at here, or roots, are going to be rational. And the best way to describe it is to sort of look at an example here. So I have some polynomial function. So a 4th degree polynomial function, so I could have at most 4 zeros. So there is this list that I can try and generate, and according to the rational zeros test, the possible rational zeros, like if this function has any rational zeros, then it's going to be in this list. So the possible rational zeros for this function are going to be all the factors of the constant term, which are 6, divided by all the factors of the leading coefficient, which in this case is a 1. So all the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The reason it's plus or minus is because I could take the positive or the negative factor of 6. So 1, 2, 3, and 6, and then all the sign changes. And then all the factors of 1 are just plus or minus 1. So this list here, when I take this this quotient, is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So I have a grand total of 8 options here, or 8 possible rational zeros for this polynomial functions right there. Okay, that's what the rational zeros test says. So what it does is it generates a list for you of possible rational zeros, and the way that you get it is by taking a look at the last term, the constant term, writing down all the factors of the last term, and then taking the quotient with all factors of the first term. In this case, my list is right here. So if this has a rational zero, it's guaranteed to be in that list. All right? So how do we use the rational zeros? Okay, so find all the rational zeros for this particular function. Okay, so first we're going to generate our list. So all the possible rational zeros are going to be, let's see, all the factors of 3 is going to be plus or minus 1, plus or minus 3, divided by all the factors of 2, so plus or minus 1, plus or minus 2. So I could have plus or minus 1, plus or minus 1/2 when I take that divided by that, that's 1/2. I could have plus or minus 3, or I could have plus or minus 3/2. So this is a good place to start to look for rational zeros for... Okay, so at this point, I could use synthetic division to check all 8 of these, but that's kind of a lot of work. So instead, what we want to do is actually explore some of these answers to see what we come up with, all right? So I'm going to plug this function into my calculator here, right here. So 2x to the third, so I have 2x to the third plus a 3x squared minus an 8x, and then finally a plus 3. And I'm going to zoom 6, make sure I'm looking at the standard graph. All right, so as you can see, right, I've got a third degree polynomial. I can have at most up to 3 zeros. Well, it looks like -1, -2, -3 could be 1. Not exactly sure. Looks like 1 could be. So getting back to my graph here, it looks like 1 is a 0, and 1's definitely in my list over here on the right-hand side, and it looks like -3 is a 0, and that's definitely in my list as well. So I'm going to start with one of those and use synthetic division to see if I'm on the right track here. So according to that graph here, it looked like -3 was a 0. So I'm going to use synthetic division to check. So I'm going to have 2, 3, -8, and then 3. Okay, so we're going to skip a line and draw a line and see what we get here. I'm going to add this up. So 2 times -3 is -6. That would give me a -3. And then this would give me a +9. This would give me a 1. This would give me a -3. And that would give me a 0. Awesome. Perfect. So I've just verified now that -3 is a 0. And remember, I'm supposed to find all the rational zeros for this thing, okay? So my answer, to find all my zeros, so far I found one. -3 is definitely a solution. Okay, now that leaves me with this little piece that's left over right down here. And this represents 2x squared minus 3x plus 1. I can set this also equal to 0. And I can either use the quadratic formula or I can try and factor this. So in this case, I'm going to go ahead and try and factor this particular this one. So I'm going to get this and this and this. So I'm going to get 2x and x, probably a 1 and a 1. And let's see here. Looks like -4 plus 1. Yep, that'll work for me. And so if I can set this equal to 0, I can find the other solutions. So x could either be -1/2, or looks like x could be a +1. So my total zeros then for this case are 1 and -1/2. So that's how we use that rational zeros test to get us out of it, to start us on the right. Okay, last one here. We're going to put all this together into a big problem here. We're going to solve the polynomial equation. Negative 10x to the third plus 15x squared minus 16x plus 12 equals 0. All right, so we're going to start by generating our list of all possible rational zeros. So I'm going to take all the factors of negative 12, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, yikes, divided by, holy cow, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Okay, that's a lot of zeros. Holy cow. So what am I going to do? I am not going to do synthetic division. Instead, I'm going to go to the calculator here, and I'm going to see if I can find one of these that could possibly work. So let's plug this into our calculator. Let's go negative 10x to the third. So follow along with the calculator if you can. Plus 15x squared plus 16x minus 12. All right, I hope that's right. Looks good to me. Okay, so we'll hit graph on this thing. All right, looks like I've got some options here. And it looks like 2 is a 0. So if I go over, maybe zoom in just a little bit. Maybe zoom in. Yep, looks like 2 is definitely a 0 right there. And 2 is in my list, so I'm going to go ahead and start with 2. Okay? So I'm going to check to see that 2 is a 0 and use synthetic division. So I'll have negative 10, I'll have 15, I'll have a 16, and I'll have a negative 12. All right, so we're going to bring down. And we're looking for a 0 in the remainder here. So hopefully I'm going to get a 0 down here, if this is right. So this gives me negative 20. That looks like negative 5. That looks like negative 10. That looks like a 6. Hey, that looks like 12. Looks like I'm good to go. So I've just verified now that one of my zeros is indeed a 2. Great. So how do I get the other ones? Well, the other ones are embedded in this leftover part of the equation here through synthetic division. So I'll have negative 10x squared minus 5x plus 6 equals 0. Well, this thing isn't going to factor nicely, so I'm going to go ahead and use the quadratic formula. So a is equal to negative 10, b is equal to negative 5, and c is equal to positive 6. So when I check here, I get b squared minus 4ac. I'm looking like negative 5 squared minus 4 times a negative 10 times a 6. That's going to be 25 plus 240 there. So I'm looking at a grand total of 265. So when this is all said and done, I get 265. So to solve this, I'm going to get x equals, I'm going to get 5 plus or minus the square root of 265, all divided by 20. Whoops, sorry. Oh, sorry. Hold on, I messed this up. Let's start this over again. I'm going to get x equals, so I'm going to get alright, what was I? Negative 5 plus or minus the square root. 256, all divided by 2 times a, which would be negative 20. Okay, so when you run these through your calculators here, you should get these two solutions of about negative 1.0639. So make sure you check this right now in your calculator, and 0.5639. Not a very nice answer, but nonetheless, it's still a 0. So you can represent your answer a couple of ways. You can either write those decimals, or you could just say it would be negative 5 plus or minus square root of 256 all over negative 20. That's okay with me. So the answer is all said and done. Those are your zeros. And when we go back here and we look at the graph of the function, you can see that negative 1.0639, that's this one over here. And then the 0.56, that's this one right over here. So we definitely have all the zeros accounted for. Okay, so in review, what our goal here is to find these zeros for these polynomial equations. We start by using the rational zeros theorem. We graph on the calculator. We find one that we think works. We use synthetic division, make sure we get a 0 there, and then we solve the resulting equation. All right, guys, hope that helps you out.